Hey everyone, in this video I'm going to explain how to solve radical equations where there are two radicals inside the equation. So I'm going to get started with the first example that I have here. When you have two radical equations, the first thing you want to do is separate them to either side. Usually I move the smaller radical over, so I'm going to subtract square root of x to either side. I'll end up getting the square root of x plus 1 equals 1 minus the square root of x. So now that the radicals are separated on either side, I'm going to square both sides and continue to solve. Now the radicals will only cancel on one side, and that's the left side, because this radical is over the whole entire side. So that means that the squared and the radical will go away and leave me with x plus 1. On the right side, though, there is a subtraction symbol, meaning that it is not going to cancel out the radical because it is a two-piece expression. It's a binomial. You need to do the box method or FOIL in order to solve this part. So I'm going to do the box method. So I'm going to have 1 minus square root of x and 1 minus square root of x. I have 1. 1 times negative square root of x is negative 1 square root of x. Negative square root of x times 1, again, is negative 1 square root of x. And negative square root of x times a negative square root of x is a positive square root of x squared. I'm going to reduce this now. I will get 1. These will combine into a negative 2 square root of x. And the square root of x squared just is x because the squared and the square root cancel out, so plus x. I'm going to drop down the x plus 1. And now I'm left with a single radical equation. It's a single radical equation because in this equation I only have a radical over here on this side, which is the square root of x. When you have a single radical equation, we will isolate the radical. So I'm going to subtract x to get the radical alone. What happens here is these cancel. I will also subtract 1 to get the radical alone. They actually happen to cancel on both sides. That means I have 0 equals negative 2 square root of x. And I'm going to solve for x. In order to do that, I'm going to divide by negative 2. 0 divided by negative 2 is 0. And I'm going to square either side to solve for x because the radicals will cancel. And I get x equals 0. And of course, you need to check for extraneous solutions. So I'm going to go to my original equation. I'm going to plug in 0. So if I put in 0 here, I will get 0 plus 1 plus the square root of 0 equals 1. That's the square root of 1 plus the square root of 0 equals 1. That's 1 plus 0 equals 1, and 1 equals 1. So, therefore, our answer of x equals 0 is a solution. In the next equation, I already have my radicals separated on either side. So if you notice, there are two radicals in this equation, but they are separated already. So I can go ahead and square either side to start. Now, because both of these sides are just one radical, like the radical owns this whole entire side and this whole entire side, meaning it's like one radical. Therefore, you don't need to do the box method at all. This would cancel out completely and be left with r plus 11. This squared would distribute in, getting you 2 squared, and the square root of 3r all squared. Meaning that this squared and this square root will cancel. 2 squared is 4 times 3r. The 3r is released from the square root because the squared and square root cancel out. And you get r plus 11. That's 12r equals r plus 11. I'm going to solve for r by subtracting r. I get 11r equals 11. Dividing by 11, I'll get r equals 1. And again, I'm going to check by plugging it into my original. I end up getting 2 times the square root of 3 equals the square root of 12. Right now it doesn't look like it's the same, but if we break down 12, we break 12 up into 4 and 3. And the square root of 4 is 2. And radical 3 would stay, so therefore this works, and r equals 1 is your answer. I hope this video helped. I'll see you guys soon.